Hey guys, how's everything going? This is JSer, who is not good at algorithms. I just attended the weekly contest. I managed to finish all the problems, but I got overtime. I just used the extra 10 minutes to finish the last one. Basically, the last one I have tackled it, but with some slight problems. So I'm recording this video to explain it in more details. Hope it can help. Okay, so what we get is 1458 max dot product of two subsequences. We're given the two number arrays. We need to return the maximum dot product between non-empty sequences of nums1, num2 with the same length. Okay, a subsequence of array is array, which is it's got from the original array, but the order must be kept. Yeah, so for this case, of course, the biggest one would be 2 times 3, 6, right? Yes, the subarray is 2 minus 2, 3 negative 6, and we sum them up. Product would be, dot product would be 18. For this one, 3 and 7, 21. So there's no limit of the length. Well, let's analyze the analyze the example like this. The idea is simple. Let's see. What if there is a final optimal solution, right? What if there is a final optimal solution, and now detect the relationship between our last element to that optimal solution? Let's see. For minus 6, if it is in that optimal solution, then there must be a corresponding number in the previous array, right? It might be 5, it might be minus 2, it might be 1, it might be 2. We don't know, right? But let's suppose that let's suppose it's k, right? Let's suppose it's k. It will be in here, and this is minus 6. Then actually it would be the subproblem say, what if the array before k and with the array like this, right? So 6 is used as 1, so we can only choose the subarray before 1 and try to get the product with this subarray, right? So this is a subproblem. And if it is, now we say if it is not used, okay, so it is not in the final optimal result, then it will be just removed, right? Like this. So actually, this is a relationship between the problem and the previous, like subproblem. Let's say the maximum would, let's say the product ij, which I and j is the last index of the array. It should be equal to, okay, if nums2 j is not used, of course it will be I j minus 1, right? If it is used, there might be k possibilities, I possibilities, which one it is used. So it would be then it should be loop through the possibilities and get the maximum. So max what? Okay, I'll write the comment. For k, 0 from 0 to I, and then nums2 use it. Nums2 times nums2 j nums1k, right? This. And the plus what? Plus the previous sum, right? The previous, like if you use a 5, then the maximum would be from here to here. But there's a case that we don't need to use it at all, right? The maximum might be like minus. We could just leave it be. So it would be max 0 and will be nums the product I j minus 1, right? Now k minus 1, yeah, the previous one, j minus 1. Well, this is actually the result, the solution. Let's try to implement. So of course we need to cache the ij, the ij pairs, right? There will be a new array. Okay, we say nums1 equals nums1.n, nums2 nums2.n. We initialize the result. Okay, so for each pair of ij, we're going to do the calculation. Right, so okay, as we said, if it is not used, we produced ij minus 1. So if it is 0, if j is 0, then there's nothing to be checked, right? We just update it. Oh, ij. For ij, if I 0 and j is 0, of course this the dp ij must be the head, right? The sum of the product of these two numbers. So nums1 I times nums2 j. Else if I equals 0, if I is 0, it means I is set to 2, and then dp ij would be mathmax, the previous one. J is not 0 now here, so must be dp ij minus 1. This is the previous one, or the sum, the product of itself, right? So nums I times nums2j. Else if j equals 0, you do the same. J equals, j is fixed, so mathmax dp I minus 1 j minus 1 nums 1i times nums 2j. Now if ij, all of them are not, none of them are 0, we need to check this, right? So the first one is not used, we can get it. So now we only check the if it is used. So let max product if used infinity. For that k equals I, k will go to 0. K minus minus. We need to update the max. Update to what? To it's to nums 1k times nums 2j, right? Sum with this, sum with this. So plus, it might be negative, so if negative, we don't use them. So it will be max 0 with the previous one, which is dp k minus 1. Well, k is, if it is 0, then the previous one should be 0. So here it would be k is bigger than 0, then it's the previous one, j minus 1. If not, then if k is 0, then it's 0 itself, right? So update max, and we could update it deep ij equals max. If it is used, it's max product if used. If not used, then what it is, dp I j minus 1, right? So actually, I think we could like make it clearer by merging these three conditions. But I'll leave it be. It's clear and with less problem. Yeah, I think it is good. And finally, we will return dp length 1 minus 1, length 2 minus 1. Let's try the code. Uh-oh, not a number. What? We also lock the dp. First one is cool, but the next one is not, which means I0 is cool. Now if j is 0, j is 0, but I is not 0, so oh shit, I made a mistake here. Cool. So let's try to submit. Yeah, we are accepted, and the time and complexity would be for this loop. Actually, we took each pair, every pair, right? We update it, and every time we update it with extra k, looping back through I, right? So actually, I think it should be n to the cube. And space, yeah, of course, it's okay. It's not n in the cube. Suppose the length would be m n. It should be m square n. And the space, of course, is m n. Right? Okay, so that's all for this problem. Hope it helps. See you next time. Bye bye.